Well, here's a few news articles that I thought were interesting. This one is interesting in a certain sense. We all have heard about quantum computing coming for years, and the basic message of this article is you can forget about worrying about it. Microsoft has now set the world record, the largest number of error-corrected qubits ever yet, and that number is 12. The hardware has 56 qubits. And now the problem with qubits is they're noisy, and it is very hard to error correct them because you can't measure them and then compare it to like a hash value to see if you have an error. If you measure them, you ruin the whole value of them. So you have to have strange indirect ways to detect errors, and some of those indirect ways can use hundreds or thousands of physical qubits to create one error-corrected qubit. But Microsoft has improved this to where it only takes like 4 or 8 physical qubits to add up to one error-corrected qubit, building them in like a hypercube arrangement. So with the hardware that has 56 qubits, they were able to make 12 error-corrected qubits. Now, the main reason people care about quantum computing is that in theory, it will crack RSA encryption. But the number of qubits required to crack RSA 2048 is thousands or millions of high-quality qubits. So we are very, very, very far from any hardware that can actually do anything. And that's the thing. The point is not that it can crack into it now. The point is in perhaps 20 or 40 years, or maybe never, but possibly in 40 years, they'll have a quantum computer that actually works, and then they'll be able to crack RSA. So people are moving to post-quantum cryptography now, so your quantum cryptography can survive that potential activity. But you know, the simple thing, computers get better relatively fast, but it really needs to get a lot better than it is before it's any risk to anybody, or actually any value to anybody. It still can't really do anything that a classical computer can't do. So you can make diamonds. This is apparently synthetic diamonds are now easy enough to make that they're undercutting the market. The machine costs $200,000, and you actually have to have a sort of chemistry lab with methane and clean methane and various other sources. But once you do it, you can make diamonds. And I bet it wouldn't take long to sell enough diamonds to pay for it. So the point.
The traditional way, high temperature, high pressure.
Right.
The machines.
That's right. But they made it. I don't know, but they made it smaller and cheaper. It used to be very expensive. Now, yeah. And of course, the problem with these is typically they don't have defects. The natural diamonds have defects, so they're worth more. The artificial diamonds are perfect. That's how they can tell they're fake. But anyway, so as far as jewelry goes, there's sort of a cachet. I was talking to one of my classes about Bitcoin. They said, well, Bitcoin has no actual value, right? It's not connected to a government. And I said, well, you might think so, but the only thing about it is it's rare. There's only 21 million of them. You can't make any more, and they can't be forged. And once you own it, nobody can take it. So it is just rare and hard to get, like a stamp that's misprinted or something, and therefore it's kind of a collector's item. People will pay for it just because there are only so many, and even though it's not connected to a government or anything, just being rare is enough. So diamonds are rare and gold was rare, and that made them valuable. But when you find a large source of them, that'll water them down. Now this can't happen to Bitcoin. Bitcoin mathematically is protected. They can't make any more Bitcoin, so the old-fashioned Austrian economic model said that should be the best currency. In practice, it hasn't worked out so well. I think what they've done is proven experimentally that the Keynesian economic model is better than the Austrian economic model, because money does not seem to be like water or air, where it just, if you have more of it and spread it out, it's weaker. It seems to be much more that if people are happy, the money is fine, and if people are unhappy, the money is not fine. Because we did this with TARP. When the banks collapsed, Obama just printed $5 trillion of money and just gave it away. And that should have destroyed the economy, and instead it saved it.
But that because there is a detachment between the golden standard and the money.
There is.
In another country, we would have had a nefarious effect instead.
Yes, and that's why they detached them. They detached them so they could adjust the money supply. And yet the problem is we don't really understand what effect the money supply has on the economy. It's really, we're finding out experimentally. But there have been two schools of thought. And Bitcoin is based on the old thought that money is like air or water, and simple physics applies. You take the total amount of money divided by the total amount of goods, and that's how much the money is worth. And therefore, if you print more money, the money gets worth less. But that doesn't seem to be true in practice, because we just had some sort of recessionary collapse in the dollar, and Bitcoin was supposed to stay high while the dollar went down, and it just went down with it. So it's not a hedge against inflation. Which is what it would have been if the Austrian economic model was correct.
Well, I believe it still depends on the supply-demand effect, no?
Well, supply and demand have some effect, but Not as much as you'd think, not on the global scale. On a global scale, it seems to just be like an estimate of the morale of your country. If people trust your country and they feel good about it, then the money is strong. And if people don't trust your money, the government, the money is weak, regardless of the supply.
There was an economist who
There's
said
an
that.
there's an emotional contribution to it.
Economy is a psychology.
Yeah, I said, well, that doesn't matter. What matters is the numbers, but that's not true. The emotion matters. Anyway, so this is something, I'll get to this a little later. Anyway, so I don't quite understand this. Now, a lot of courts in America are hopelessly backlogged. Like, the whole one point of the immigration problem is they don't have enough judges or anything, so they can't really try the cases, so they're just letting the immigrants in, and that's why the right-wingers get really mad. But the same thing's true of jobless claims. They haven't ruled on the unemployment claims from the pandemic, which is getting to be several years ago, because they haven't crossed through it. So they're switching to AI to rule on the claims. Now, AI can read a document and make a judgment, like it can read a movie review and decide if it's positive or negative, and it can probably read a legal document and see if it complies with the rules, sort of, but it will make mistakes. So people are worried about this. The part I don't understand is they say if the AI will make a decision and then the human will just take a quick look at it and verify it, and they say after that's over, the courts can't fix it. The court doesn't have the right to overrule the claims adjuster, which is a very strange statement in here. I thought courts could overrule anything. But anyway, we'll see what happens to this. However, this is probably true. A lot of white-collar paperwork jobs might be replaceable by AI to some extent. And we're just beginning to see. We'll see how well this works. The earlier attempts to replace these kind of work with AI have been disasters. McDonald's gave up on having the drive-through order done by AI, and a weight loss clinic gave up on having the telephone operators replaced by AI because they did a terrible job. So we'll see. AI isn't yet ready to really replace people, but maybe. Everyone's trying to do it, and they might succeed. So Microsoft has had a bug which prevents you from putting on the patches for a long time. So a lot of machines are not really patched. They've had several patches that had to be rolled back and such. Now they've apparently finally tracked it down. So that'd be nice, because if you're back on your patches, then you get hacked with known attacks. See if I'll find the best ones here. Yeah, this one was interesting. There's a charger for cars called the Autel Maxi charger, and these guys decided to analyze its security, and what they found was it's got a lot of wireless connections like Bluetooth and so on, and they found this very nice research paper. They found the hardware, then they got the firmware. Now this is a huge, this is a big part. We should have a hardware hacking class here, right? But you keep cutting half and everything, so we don't have it yet. But you can learn to do this. When you have hardware, any kind of device, a router, any device, it has firmware, a memory on it, and the firmware is usually obfuscated and packed. So they try to prevent you from seeing the firmware, but they never do anything very smart. So here, what they did, they found the firmware on the website, and they figured out what it was. They found that it was obfuscated. It had base 64 looking stuff, but they couldn't base 64 decode it, so they figured it was just a modified base 64, and this is all it is. All it is flip the upper and lowercase letters in base 64 and then change Y's to 7s. And so they figured that out, and they were able to unbase 64 it. Then the firmware was still encrypted, but they noticed there was a pattern repeating every 256 bytes. So they figured it was a 256 byte XOR, and they had to guess what the key was. And they figured out how to deduce the key by doing a combination. So the point is, they figured out that it was XORing with a key and then adding something, and they were able to find that if you find a 0 byte, it'll give you one of the parameters right away. And 0 bytes are quite common in software, so you can just find the common byte, and that's the 0. And so on, using various tricks, they took a couple days of struggle, and managed to figure out the keys and decrypt it all and get in the firmware. And when they were in, they found a deliberately coded backdoor, secret administrator account, built into all of them with the same password, which is amazing how many people do this. It used to be common practice 30 years ago, but nobody should be doing this anymore. But anyway, they had a secret backdoor in it, which is very rude and interesting. It's a good example of security research. You see how they did it. None of it's really that difficult, but you have to be a little bit familiar with the stuff so you don't just give up. But the steps are not that complicated. And this I thought was interesting, but I may not get to it today. So they did gene therapy to help people who had a missing gene. Their eyes didn't grow correctly, and they were able to restore sight to the blind. People who couldn't see at all at night can now see pretty well at night and 10,000 times less light. So there are several diseases like this, diseases that are based on a simple genetic flaw, that they are fixing with gene therapy more and more as we go ahead. And I don't think I'm going to bother with this one today. Now I'm just going to stop the news and move back to the official stuff.